Our eco-design and eco-efficiency advised measures start with the production process, which represents almost 89% of the entire ecological costs. So any measure taken in this area will have a substantial impact in the final outcome. Substituting current machines with newer, more energetically efficient counterparts is an option, though the high investment costs might make such a measure unattractive. Perhaps the substitution of a machine that is involved in other processes and is more intensely utilized would mean a quicker cash return. Another possible improvement would be the reduction of the thickness or change of the profiles of the blocks supporting rims. However, due to software-related constraints that made it impossible to change the profile and thickness of the rims, a response analysis of the current rim to a concentrated force was realized. For this, the structural calculus software ANSYS was used to simulate the rim's behavior when under a load of 100 kg force in one of the extremities. A mesh was attributed to the 4 bars that make up the rim, and the respective interbar connections were attributed. In this video, the total deformations of the elements are represented. As it can be seen, the rim is sufficiently strong to endure a relatively high load, so we might equate a reduction of the material. Additionally, changes could be made into the welding process. During that process, the major environmental aspects are the use of electrical energy and the interaction with the atmospheric air through the release of gases and fumes, especially the metallic ones, which can contaminate the atmospheric air where there is welding, with the possibility of propagating to the exterior, reinforcing the need of a strict emissions control. As a control measure, we proposed implementation of ventilation systems with an exhauster and filter in workstations. This measure intends to neutralize the toxic agents and pollutants, preventing their propagation. Finally, a measure that would reduce drastically the ecological impact of the production process would be the replacement of all stainless steel components with a different material. Our suggestion would be the use of some sort of plastic, for example, an agglomerate of an industrial mix of recycled plastics. This would reduce total ecological costs by 70%, an enticing figure. Naturally, such an option would radically change the entire production process and machines involved. So, this change would have to be extremely well thought through. An easier step to take in terms of the illumination would be the replacement of light bulbs in some artificially lighted areas with transparent tiles, seizing the gratuitous sunlight and thus lightening the workflow. A measure that could reduce the environmental impact during the transportation process, even though this is quite negligible, would be the replacement of the means of transportation of the gutters coming from Coroflexes and the lock coming from Ojmar, substituting the current van for a 16-ton lorry. This measure would allow us to reduce transportation-related ecological costs almost up to 70%. One should also equate the possibility of having local suppliers, thus reducing the number of kilometers that different components must travel before arriving at the factory.